Hey guys, so I'm reaching out to you because I was looking at our discussion board and saw that people are having difficulty with problem number 4 from class 1. So I'm just going to actually post this to try to help you guys out, and maybe if you hear someone actually walking through, it'll give you guys a little bit of a hand. Just know that tomorrow during the virtual lesson again, class number 2, you guys are going to see a similar problem, but perhaps with a little bit of a different approach, so perhaps that will help. So I'm going to kind of just walk you guys through number 4 from the classwork, and hopefully this post will give you a little bit of a hand. So it's saying, suppose you have 100 meters of wire, right? So 100 meters of wire, there's some amount here that you have your wire. And you're going to be cutting it into 2 separate pieces. Now, I know that the question says X and it says 100 minus X. Tomorrow, I'm going to be using a little bit of a different approach there to kind of help you guys out in terms of solving this. But let's just say for now, you have one side or one portion that is X and the other portion here that is 100 minus X, okay? And you're going to bend the first one into an equilateral triangle there. So we know that we have an equilateral triangle. And you also know that the second one is going to be cut into a square. So just to give you a little bit of a visualization, you have your triangle and your square. I'm going to skip part 1 for now, and I'm going to move on to part 2. Because part 2 says, write down an equation expressing the combined area for the 2 shapes. So let's say here we had a triangle, and let's call each of the sides here S, since it's equilateral, all the sides are going to be the same. And let's say for the square here, let's say all the sides are Y. So we got Y, 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 and Y. Okay. To find an expression for the total area, the area is going to be equal to the area of the triangle plus the area of the square, okay? In the question, we did give you the area for the triangle. So the area of the triangle there would be equal to radical 3 over 4 with your side squared. That's going to be the area of your triangle. For the area of the square, however, the area of the square is going to be y squared. That is your total expression for your area. Now the problem is, however, this whole thing is expressed a little funky because we never really dealt with functions where you have 2 variables and you're trying to maximize that function. So we need everything in terms of 1 variable. In particular, we're going to be trying to express it in terms of X, okay? If you think about the fact that this whole perimeter for that triangle, if you look at the triangle, the perimeter for the triangle is equal to 3 of the sides all together. If you know you used X to create that triangle, that means that 3S, or 3 sides all together, would have to produce X. If we take this and we solve for S, S is equal to X over 3. That means that in this expression here, we can actually substitute in for the S. And we can make this area here equal to radical 3 over 4 times X over 3 squared. In addition to that, we can find an expression for Y that's also expressed in terms of X as well. So if I use here the fact that this perimeter would equal to 4Y, or Y plus Y plus Y plus Y, all the 4 sides added together, okay, we know that 100 minus X would have to equal to 4Y. If we divide both sides by 4, we get 100 minus X over 4 is equal to Y. We can then substitute that expression in for Y, and we can see that we have 100 minus X over 4 squared. Notice that that just got substituted in for the Y in this expression over here. Notice now that your area function is all expressed in terms of X. Everything here has x's on it. There is nothing else there, okay, except for x's in that expression. We are then able to simplify so that we can take a derivative. Here's my suggestion. My suggestion is this guy here, that's pretty simple to square out. So your area would equal to the square root of 3. We'd have x squared on top, and on the bottom, since 3 squared is 9, if I multiply that by 4, that gives me 36. This guy here, though, however, why don't we leave that in terms of the parentheses? Nobody wants to FOIL out that numerator and have to deal with something ugly. We can actually just use our chain rule. So if I keep this as 100 minus x over 4 squared, I now have an expression for area that is solely based off of x. There's no other variable in there at all. If I try to take the derivative now, because remember when you want to maximize or minimize, that means that we're going to have our derivative and set our derivative equal to 0. We can take this expression and say, all right, I'm going to use the power rule on this term. So that would be 2 square root of 3x over 36. Don't forget to keep your denominator with you. And then I'm going to use a chain rule here. Notice you have an inside function. Here's your inside function. That is your inside. And then you have your power. So first, let's deal with the power. So that would be 2 times the inside staying the same to the first power, and then times the derivative of the inside. Note when you're taking the derivative of the inside, this is the only term with the x. So your chain rule here would have to be -1 over 4. Okay? If you're confused about where that's coming from, just take a little side note here. Okay? That inside that parenthesis of 100 minus x over 4, that is the same as 100 over 4 minus x over 4. And that's why our chain rule here, that's going to be that -1/4. If we clean that up, I'll move this up a little bit, okay? If we clean that up and now I know my a prime is equal to 2 radical 3 over 36x, I just moved the x out so it looked more of a coefficient to you, and minus 1 over 2 times 100 minus x over 4. Again, just combining the 2 in front and the -1/4. We know that this derivative must equal to 0 in order for us to be able to, minimize this area. So if that's the case, then we have 2 radical 3 over 36x. If I move this term here over to the other side, that would have to equal to 100 minus x over 8. Note I just multiplied the two denominators, the 2 and the 4, to give us 8. We can cross multiply it this time. That would give us 16 square root of 3x is equal to 3600 minus 36x. Okay, we can then move that 36x to this side here. We have 16 square root of 3x plus 36x equals to 3600. And last but not least, we could factor out the x. That leaves us with 16 rad 3 plus 36 equals to 3600. And then x would equal to 3600 over 16 rad 3 plus 36. Okay? If you note, that is the same answer that is on the answer key that was provided from Dr. Summers as well. We will be looking actually at a different method tomorrow to use that might make it slightly more simple.